What's up, everybody? This is Gabriel. So, I have the Story backend and MCP server running locally, and the Story app connects to it over a WebSocket. And I added the MCP server to Cursor's config so I can drive the Story app from Cursor. That is the demo I want to show you now. So, again, we have our backend service, which we are currently called Composer. It's running locally in Docker. It's got the entire API, a REST API, and it's got an MCP WebSocket API available at localhost on port 10,001. And then this is the Story app, and it connects to the backend over WebSocket at localhost 10,001 at basically API v1 MCP DAW, and it passes in the token, which is just your JSON web token. We create each user a JSON web token based on the UUID, which is generated from the app. And when it's connected, you can see down here. So it says green Composer. So we know that the front end is connected to the back end over a WebSocket. If I jump over to the back end, here you can see mcp.json. I don't want to click into it because it has my jot in there, but effectively you just add a big JSON object in there, and it tells Cursor to use your MCP server, and it gives it whatever it needs, in our particular case a URL and a jot token, etc. And so now Cursor is aware of our app, and if we go to Cursor and we say something such as call story read project, so you can see it knows we want it to call that tool call, and boom, you can see right there. So it came back in this JSON. Name MCP project, which is what the name of our project is. You can see it here. Tempo 120 beats per minute. You can see it at the bottom. Key signature C. Numerator, denominator for the time signature 4/4. That's correct. And then that's all that there is in there so far. Okay, so that's pretty rad. What if we were to do something like, say, create a nylon guitar track. All right, let's see if we can get the API correct. Give it a couple of seconds. I didn't give it even what the API is. It's going to read the docs real quick. It'll figure it out. There we go. So it did. It had to read the docs. So now you can see that it called. I told it to create a new nylon guitar track, and you can see here now in Story we have nylon guitar. And so now if I say something like change the nylon guitar track to a waveform icon and have the color be pink. Let's see if it'll figure it out here. So it's calling that, got success, and now it's going to change the color, got success. And so we can see it changed it from blue. It was a keyboard and it was blue, now it's a waveform and it's pink. So you can see that we're driving Story strictly from Cursor. I mean, that's literally what's happening. This is Cursor, this is Story. We're driving Story through Cursor using MCP. And so now any MCP client, we're talking Claude, or obviously Cursor, or any other modern agent which can communicate over MCP, can now drive Story. And you can see here we have this MCP tools reference. We have 41 tool calls right now. It's pretty much the entire app. If there's anything missing, of course, we're going to add it. So there is extensive tool coverage. The digital audio workstation is built from the ground up. Here you can also see, similar to Cursor, this is built into Story. This is you can see over here, you can choose which model you want. They all have brains if they're thinking. You can see how much budget you have left, how many requests you've made. And then over here, I could do something like, what is a Dorian scale, question mark. And you can see it's going to say reasoning, and now it's doing internal chain of thought reasoning and streaming it back in real time. And then it's going to give us an answer streaming in real time. It tells us how long it reasoned and it collapses. Very similar UX. So this is using server sent events or server side events, whatever SSE is. That's what's happening here. This is a native Swift app, of course, native macOS app, and that's using SSE. And then this is connected over WebSocket. So we're able to have both of those experiences. You can drive it from here or you can drive it from here. The way it works is when you put your natural language in, we have a intent engine on the back end, which is the composer service that basically pulls apart your intent into 3 trains of thought. It could be reasoning, which we saw here, and it will either use retrieval augmented generation to search our docs and answer you in natural language. So for example, if I say, how do I create a new track in Story? Question mark. So it's saying reasoning. And so it says, I'd be happy to help you create a new track. So it's saying, you can create MIDI tracks or audio tracks. And so see, it got this from our docs. It knows this already. And then it's even asking for clarity. It'll ask for clarification. And so it can do editing where it edits this. It can do composing where it creates MIDI, and it can do reasoning, which is what you see here. And so you can drive it from the front end like this, or you can drive it now through MCP using any agent. So this is Stori, and the front end already is completely open sourced under MIT, and we're cleaning up all this back end, and we're going to be releasing it as well. Our intention is to really help set off the creative renaissance, and we want Stori to be like a huge part of that for people who want to have digital audio workstations, professional workflows which are agent driven. All right, that's the demo. Thanks, y'all. Peace.